The lying patient reports a cardiac arrest. However, there's moisture on his opened collar, which indicates neck discomfort and excessive sweating. Tucked shamefully under the covers is a McDonald's 10-piece chicken McNugget. And lastly, his heart rate is nowhere near a cardiac arrest. Therefore, these are clear symptoms of a heart attack. Damn it! Foreman! Foreman, you look especially girly today. Did you change your hair?
First of all, I'm not foreman. Second, you don't need defibrillators when someone's heart stops.
What are those for then? The added shock value?
I'm going to tell you what defibrillators are actually for and how they work. So what is a defibrillator? A defibrillator is a machine used in a medical emergency to restore any normal heartbeat. In other words, a heart arrhythmia, aka a heart fibrillation, hence the term defibrillator. There are three major types of defibrillators: an automated external defibrillator, an implantable cardioverter defibrillator, and a wearable cardio defibrillator. For further explanation, an AED is used in medical emergencies, and an implantable/wearable one is prescribed by a doctor for someone with sudden cardiac arrest. In this video, we will be discussing AEDs.
So, how does an AED work? Well, Pross from HowEquipmentWorks.com uses a great analogy for this. Imagine a classroom as the heart, the teacher being the natural pacemaker system, and the students being the heartbeats. Ooh. When the teacher commands the students to do something, they do it. But when one student starts talking to other students, the whole classroom descends into chaos. No one is in sync. This situation represents a ventricular fibrillation, also known as a VFib. When VFib occurs, blood cannot be pumped to the rest of the body. So how does a defibrillator solve this problem? The battery in the portable AED fills the defibrillator paddles with electrons when turned on. The charged paddles are applied to the patient's chest, then, using static electricity, transfers the built-up energy to the heart. In hospital settings, conductive gel is applied to the paddles before coming in contact with the patient to increase conductivity. When this shock is delivered, the heart briefly stops, then starts again. Restarting the natural pacemaker system. That's totally wrong.
Static electricity is crucial for the defibrillation process to occur.
Why?
Well, I'll tell you. Static electricity is defined as the imbalance of electrons on the surface of a material. This imbalance is typically formed by friction between two objects. When friction occurs, the object with the lower electron affinity loses its electrons, and the other one gains them. Now, one has too many electrons, and the other has too little, thus creating the imbalance and the shock that occurs when both of them become neutral again. So how does this relate to defibrillators?
Tell us!
You know how I said?
The battery in the portable AED fills the defibrillator paddles with electrons when turned on.
What that essentially means is that the electricity stored in the battery flows to the metal paddles, giving it an excess in electrons. The atoms need somewhere to release all this unneeded electrical energy. So, when coming in contact with a grounded object, in other words, the patient, electricity shocks the heart. So yeah, defibrillators are an amazing way static electricity can be used to save lives.
Okay, Newton. What does that have to do with our patient?
Oh right, you can't restart the heart if it's already dead. How don't you know that already? Aren't you a doctor?
I'm a 17-year-old girl.